Hello everybody, and let's get started on this review packet that I hope you're not doing right before the exam. Let's get started. First thing we're going to do here is solve these basic trig problems, and to do that we are going to circle our angle and label our three sides as opposite, adjacent, and hypotenuse. And you can see here that we don't actually care about the opposite because there's no variable or number, so I'm going to erase that. Which means we're dealing with A and H. So just as a reminder, we've got SO, CA, TOA. Okay, so we are dealing with A and H, which is going to be cosine here. All right, so we're going to have cosine of 45, which is root 2 over 2, equals adjacent over hypotenuse, which is x over 12. Now we're going to multiply by 12. Here the 12s cancel, and I am left with x equals 12 cosine of 45 degrees. And we do need to simplify that, put it in our calculator, and I get 8.5. You should check that this answer makes sense. Could this be 8.5? Yeah, absolutely, I think that makes sense. All right, next problem here. Again, we're going to circle our angle, label our sides. This is our opposite. This is our hypotenuse and our adjacent. Here we do not need the adjacent. We're dealing with O and H, so that's going to be sine. So that's going to be the sine of 35 equals opposite, which is 20, over hypotenuse, which is x. Notice here that we have x in the denominator, so it is going to be a divide problem at the end. Let's go ahead and just work it out though. We're going to times x on both sides. Here the x's cancel. We're left with x of sine 35 is equal to 20. I want to get x all by itself, so I need to divide by sine 35. Okay, the sine 35's cancel. I'm left with x equals 20 divided by sine 35. And just putting that in my calculator, I get 34.9. There we are. Okay, notice how this next question is asking us to go to the nearest degree, and also we're trying to find an angle. So we should be using our inverse trig functions. Let's start by circling our angle, going across, that's our opposite. Across from the 90 is our h, and the remaining is our adjacent. I'm going to erase my hypotenuse, don't care about that. And now since I'm finding an angle and I've got OA, that's going to be that my angle is equal to tan inverse of opposite over adjacent, which is 19 over 15. Put that in my calculator, and my angle is equal to, rounding to the nearest whole number, 52 degrees. All right. Next one here, on your test, I'm actually going to ask you to do this 3 different ways. So we do need to get in this habit. So I'm going to circle my angle, go across, that's my opposite, across from the 90 is my h, and then I've got my a. So I'm just going to quickly set up all 3 of these answers. I'm going to have sine inverse of something, cosine inverse of something, and tangent inverse of something. Well, sine inverse is going to be opposite over hypotenuse. In this case, it's going to be 72 over 97. Cosine inverse is adjacent over hypotenuse, which is 65 over 97. And tan inverse is opposite over adjacent, or 72 over 65. All right, doing all those in my calculator, I get 47.9, which does round to 48 degrees. And you really should check all 3 of these to make sure you've got them right, but they do all equal 48 degrees. All right. Next question here says, from an airplane at an altitude of 1,000 meters, the angle of depression to a house on the ground measures 14 degrees. Find the distance from the plane to the house. I'm going to go ahead and draw a little airplane right here. And put this up here. And I'm going to draw my Z. Okay, we should know that angle of depression is right here, 14 degrees. And we are also told that the plane is 1,000 meters off the ground. It has an altitude or height, so we know that this is 1,000 meters. All right, and it's asking from the distance from the plane to the house. Well, if the airplane sees the house at an angle of depression of 14, that's implying that the house is here. So if it's asking for the distance from the plane to the house, it's asking for x here. Now, that 14 degrees is not in our triangle, so I need to do 90 degrees minus 14, and that gives me 76 degrees here. Or if you wanted, you could have put 14 degrees right there and solved your triangle that way. That's more than fine. All right, so let's go ahead and redraw this triangle without all that madness in it. Basically, I have 76 right here. I have 1,000, and then I have a right angle, and I have x. Okay, let's go across from our angle. That's my opposite. This will be across from my 90 is my hypotenuse, and the remaining is my adjacent. So I do not care about my opposite. I only care about my adjacent and my hypotenuse. And so that's going to give me cosine of 76 is equal to adjacent over hypotenuse, which is 1,000 over x. Okay, get rid of the x or in the division by multiplying. That's going to give me x cosine 76 is equal to, the x's cancel, 1,000. Then divide by cosine 76. Cosine 76 cancel, and I'm left with x equals 1,000 divided by cosine 76, which is 4,133.6 feet. I didn't tell you how to round that, so if you rounded it differently, that's more than fine. All right, here we go. Lauren stands on the ground 12 feet from the base of a flagpole. So let's go ahead and draw our flagpole. Okay, and then I've got Lauren is over here. She's got long, flowy hair. And it looks like she's dancing. And so we have that Lauren stands on the ground 12 feet from the base. Base means the bottom of the flagpole, so this should be 12. And she sees the top of the flagpole with an angle of elevation of 43. And if you can't see that Z, it's right here. I'm going to get rid of it though. And how tall is the flagpole? Well, that's going to be an X right here. All right, labeling our sides, we go across. This is my opposite, across is my H, and then we, of course, have an A. We do not care about our hypotenuse. We care about our O and our A, so we have tangent of 43 equals opposite over adjacent, in this case, X over 12, times 12 on both sides. I get 12 tangent of 43. Here my 12s cancel. I get X. Plug that into my calculator, and I get 11.2 feet. Again, I didn't tell you how to round, so I'm fine with anything that you do there. All right, next question, a straight stretch of mountain highway. Say that 10 times fast. Straight stretch of mountain highway. Guess it's not that hard. Anyway, it increases at a grade of 9 degrees. If you have driven 13 miles on this road, how many miles have you risen in elevation? I hope you drew your Z first. I'm going to have my 9 degrees for my angle of elevation. And it says that I have driven 13 miles on this road. And I want to know how many miles I have increased vertically. So there's my X. Labeling my sides, I've got my opposite, my hypotenuse, and my adjacent. I do not care about my adjacent, but I do care about O and H. So that's going to be sine. Sine of 9 degrees is equal to opposite over hypotenuse, or X over 13. Times both sides by 13. And I get 13 sine of 9 is equal to, here my 13s cancel. I'm left with X. And then putting that in my calculator, I get 2.03, which I'm fine with rounding to just 2 miles. Again, you can round it however you'd like if I don't indicate how to do so. Okay, number 6 here. I'm going to go ahead and draw my Z because I know it's one of those problems. And I know that a straight stretch mountain highway drops 1.7 miles, so I'm dropping 1.7. after driving 15 miles on the road. What's the grade of the road? Well, it's asking me for how much it drops, so that's right here. But also we know that that's how much it rises, so that's right here. So I think I would just put that X in the lower section because it's in my triangle. So I'm going to go ahead and erase this top one. They're the same, so it's no big deal. All right, I'm finding an angle, so I need to make sure I remember to use inverse trig, but first let's label our sides as opposite and hypotenuse, and of course this is adjacent. It looks like we only need the opposite and the hypotenuse, and we do not need the adjacent. So since this is finding an angle, I'm going to have sine inverse of opposite, which is 1.7 over 15. Putting that in my calculator, I get roughly 6.5 degrees. All right, find each measurement indicated. So this to me is a perfect setup for law of sines. I'm looking for AB, okay, which is right here, and I'm going to call this C, right, because it's across from my C. And I notice here that I've got angle C, don't have side C. I have side A, but I don't have the angle. Well, could I find the angle? Yeah, sure, absolutely, right? We've got a triangle where they should all add up to 180 degrees. So if I add up 44 plus 39, and then I take that answer and I do 180 minus that answer, I will get an answer. So 180 minus, what's 44 plus 39? That's an 83. Subtract 180 minus 83, and I get a 97 degrees, meaning I can sneak in right here a 97. Okay, now do I have 3 of the 4 pieces of information? Well, let's see. I have the 30, I have the 44 degrees, I have the 97 degrees, and I'm looking for my C, so I've got 3 of the 4. So notice how I've got C's and A's here. So that's going to be, give myself some space here. That's going to be sine C over C equals sine A over A. So my sine C over C is going to be sine of 44 over C. And just, I didn't label this, but this is my A because it's across from my angle A. All right. So I've got sine A, which is going to be sine of 97 over 30. Let's go ahead and cross multiply. This gives me C sine 97 equals 30 sine of 44. Keep in mind I'm solving for C, so I need to divide by sine of 97 on both sides. And then these cancel out, and I'm left with C equals whatever this division is. Remember to close your parentheses on the sine of 44, and that gives me 21. This does say round your answer to the nearest tenth, so really technically I should have 21.0. And we do have miles as well. All right, next question here. Oh, guess I can't do that. I'm trying to find AB, which is this side right here. And so I'm going to label that as my side C. And that's really good news that I do have, in fact, the angle across from it. And the only other side I have is 31, so I'm going to have to calculate this angle because I know I'm going to have to use the A's in my formula. So I add up 62 and 47, I subtract it from 180, and I get 71 degrees right here. All right, now let me go ahead and circle this. Okay, I've got an A here across from angle A. So it's really going to be the same formula as this one right here. So let's do sine C over C. So that's going to be sine of 47 over C equals sine of A, which is sine of 71, over my A, which is 31. Let's cross multiply. That's giving me C times sine of 71 equals 31 sine 47. I'm I'm going to divide by sine of 71. And that's going to cancel out right here. And I'm left with a C that's equal to 31 sine 47 divided by sine of 71. And that's equal to 24. And since we're rounding to the nearest tenth, I'm going to go 0.0. And we are talking about feet here. Right. Next too, you might notice here that we are dealing with angles. Okay, so here we actually have to use inverse trig at the end. So first of all, I'm going to circle my A and my side A here. Call that A. And if I'm finding angle C, I'm certainly going to circle angle C and the side C as well. And it looks like this is a really friendly problem that's given us all three out of the 4 pieces of information that we usually start with. All right, so here we go. We're going to have same thing as we had here. Sine C over C equals sine A over A. All right, so here we go. So sine C is going to be sine C over C is 12 equals sine A, which is sine of 89 over 24. Okay, good stuff. So I'm going to multiply this through, and that I get a 24 sine C is equal to a 12 sine of 89. Now divide by 24. And I get that my sine of C is equal to 12 sine of 89 divided by 24. Now, of course, I need to solve for C, so my measure of angle C, or you just write C if you'd like, my measure of angle C is going to be equal to sine inverse of 12 sine 89, close my parentheses, divided by 24. And I do that in my calculator, and I get that the measure of angle C is equal to 30 degrees. And again, I should be rounding to the nearest tenth for the direction, so I should put 30.0 degrees. And degrees is our units. All right, let's check out this next one here. So we're looking for angle C, so I'm going to circle C, right? That is my side C, and it looks like it's a perfect setup for A. So again, we're going to have sine C over C equals sine A over A. So that's going to give me sine C over my C, which is 30, is equal to sine A, which is sine 37, over 35. Let's go ahead and cross multiply. Okay, that's going to give me 35 sine C equals 30 sine 37. Divide by 35 on both sides. Okay, and I get a sine C is equal to 30 sine 37 divided by 35. Now I need to take sine inverse of both sides, and that's going to give me that my C, or my measure of angle C, is equal to sine inverse of all of this. See if I can fit it in here. Nailed it. And I'm doing that math in my calculator, making sure you put parentheses or close parentheses with the 37. All right, and I get 31 degrees. So I've got my measure of angle C equals 31.0 degrees. All right, thanks for watching pages 1 and 2. I'll be back shortly.